basically after like the third attempt, I'm getting universal jailbreak that decodes reasoning of anthropic models. I think this like still shocks me like the most, you know.
And what's the paper called?
Good question. I don't remember. It was a thought in my mind, but I think it's called stealing reasoning
traces from proprietary LLM APIs.
Proprietary LLM APIs. Yeah, that's right.
And you nearly called it the elephant in the room.
It's the dream. The dream. It'd be nice to call it.
Not allowed to.
No, I think it's allowed is a strong statement.
Stop.
I think it's like definitely an elephant in the room full of China.
A quick orientation. So recent AI models, they think before they answer. Sometimes the thinking is pretty inscrutable. In fact, it's more inscrutable than we realize now that we can look at it. So yeah, the models encrypt that thinking. They hand it back to you in a sealed envelope. And Ilia Shumailov and Alexander Panfilov noticed that this seal was weak. It wasn't really working as expected. And the results were explosive.
You can decode reasoning traces of frontier LLMs, of like the most, advanced ones like GPT-Sol. Using the smaller LLMs within the same family, you can like poison some thought. And like when you are replaying, some other users run, agent might do some weird stuff just because it's reasoning.
It's been a long time. So what happened? I've seen on Twitter, you released something. It blew up a little bit. There's been 3 million views in 40 hours or so. What happened? What took place? Why is everyone talking about this? Why? What happened? What is this paper about?
Okay, we show that you can decode reasoning traces of frontier LLMs, of like the most advanced ones like GPT-Sol, using the smaller LLMs within the same family, and this allows like big threat models to be enabled. You can steal secrets from user sessions. You can do training on this decoded reasoning traces. You can do like prompt injections. You can do jailbreaks, all this exciting stuff. And we decode a bunch of traces. We show that some of them look really weird, and models sometimes think in white spaces, or like summarizer is sometimes unfaithful, and like it has a lot of safety implications. Or like,
wow, that sounds like a big deal. So, and you say it affects all model providers?
We tested Anthropic, OpenAI, and Google, and they all share the same vulnerability that thoughts of bigger models can be replayed into smaller models, and this allows like not very sophisticated extraction attacks on reasoning.
So how does this work? How do we end up in a world in which all of the frontier models share exactly the same vulnerability? How is that even a thing?
That's a good question you ask them. It's the same people. Same people doing the same things.
Do you think this is a structural issue? Can we fix this?
I think there is definitely some stuff you can think like on the architectural side. I mean, there are like different level of mitigations. I think they all can do some sort of revision of architecture. They can do system level mitigations, like some safeguards around this. They can do model level mitigations, like we did with jailbreaks already. So yeah, it can be mitigated to some extent.
Okay, so but taking a step back, so have you stolen the models?
Stolen what?
Models.
No, we didn't.
So what have we stolen? What is possible now that we've stolen the thoughts, reasoning? Is it fair to call it thoughts?
We didn't steal anything, right? So what we did.
The paper is called stealing, isn't it?
Is it?
I know somebody said it's like fair use.
Yeah, it's fair use. Yeah. So no, what we did that, like when you query an LLM, a so-called reasoning model, it returns to the client this encrypted reasoning blob, which like deemed to be secret and not observed by user. And what we show that you can just decode it and you can see the content of it. And this is what we did. We just collected a bunch of reasoning blobs like this for all the providers, for like Anthropic, OpenAI, Google, and we decoded them and we just showed how they look like.
Okay, so but can you explain, why do people encrypt them in the first place? Why do we give them back to the user? Is there a reason why we do this?
I mean, I guess the reason why we give them back to the user is because of stateless architecture, and I guess it's cheaper, and maybe there is some policies about like how user data should be handled or should not. I don't know. But what was the first question?
It sounds very complex. Can you actually explain this once again? Like why? So I'm a model. I reason through a problem.
Yeah.
I produce this reasoning blob.
Yes.
And I guess this is not the final answer, or is this the
Yeah,
final?
it's not the final answer. It's
Then
like,
I give it back to you, and what do you do with
what
it?
you do, you are a model, right? Like you are producing an answer. Answer consists of two parts. One is reasoning, which like invisible to the user, and other is like visible part. And you send both parts to the user. Then it's like stored on the user side, or like if you are doing like your Claude Code session, you can continue asking like new question, like maybe you can see some tool calls there. Maybe you want to fork a conversation and then you have like a new file like this. Or maybe you want like to rewind this conversation from like prior point in there, and you just like, you know, go back and like goes like this whole conversation prior to some point goes back to like on server side, and it's like getting replayed there, and you like continue from it.
What's the point? Why do we give back the reasoning to the user?
That's a good question.
Okay. Well, at least we encrypt it.
At least it's encrypted, yes.
Okay, so and what happens with this encryption then? So I give it back in an encrypted form. So what did you do with it?
I mean, so what we show that this encrypted reasoning blobs, they are like portable across users. So like if you have blobs that you produce in your session under your Claude Code account, I can use it. I can like basically take your trace and like replay it, and like my model will interact as if like I produce this reasoning blobs. You can, for the reasons like downgrading the model, I know like from Opus to Sonnet, those are portable between models, and they are also for, I'm not sure why exactly, but they're like portable within the conversation, right? So you can just basically take a thought out of Opus conversation and put it like in absolutely random place and like random fabricated conversation with a haiku, and like haiku would interact with this thought.
Oh, interesting. So transferring this to us, like say I'm a model.
Yes.
You're basically saying I can be asked a question,
Yes.
reason through it, then produce you an answer. You can then take my reason,
Yes.
plug it into another conversation, and replay it as if I reasoned in a certain way with respect to some other question.
That's correct. Like what this replaying thing, what it makes is just like you construct a new like completely fabricated conversation window where was some random question. It was just like this reasoning that you had and some maybe some random answer, and then I can just like construct it in a way that would allow me to extract this reasoning.
I see. So you're basically saying you're injecting fake reasons into some conversations, and then with these fake reasons, you can launch a variety of different attacks.
Yes.
I see. I see. So some of those attacks are forcing, I guess, the model to produce outputs that it's not supposed to be outputting.
Correct.
Some of them are violating some privacy.
I mean, privacy is violated by the fact that like model actually can state the thought as it was. And sometimes in certain like user sessions, I know maybe you ask like to sanitize your like repository before you post it on GitHub, or maybe there was some bug, model need to log in into some service, and it's like, oh, what's the password? What's wrong with the password? Password looks like this, and model like tend to reason through these things. And if you like for whatever reason want to share this conversation online, and even if you like did some sanitization on like visible part, you just removed all API keys, like all passwords, but you like the encrypted blobs are still there. I can like download it from the GitHub, and I can decode them, and I can see like what the password that what model was thinking about.
I see. So like, let's translate this a little bit into more normal conditions. So say I'm asking the model about, say, my medical conditions. I give all of my medical informations into it.
Yeah.
And then it produces me some sort of an answer.
Yeah.
And then you're saying that if I share this conversation with somebody else, then they can recover all of my medical information out of the reasoning thoughts?
If you share
Even
it,
if it does not appear in the original question?
yes. I mean, if you like, if you care, you know, and you sanitize the original question, like removed all your information and like you move this information out of the answer if it was leaked.
Yeah.
But you like, if reasoning blob is kept, yes.
I see. Wow. It's kind of cool, isn't it? Okay, so and can you talk through, like, presumably outside of privacy, there are also safety implications around
Yeah.
it.
I mean, there are a lot of thoughts about like eligibility of the reasoning because, you know, models are doing stuff. You want to monitor them. There was like this incident with the Hugging Face, and like you really want to see what they think about to like prevent them from certain things. And you use typically some other LLMs to look at the thoughts. And if model is reasoning in some, you know, super obscure way, or like using non-human language, or like as we observe sometimes it like uses this, you know, quotes, empty space quote, and
In non-human languages. What?
it's just like it's very, alien-like. It has like this weird phrases like but marinate, vantage, theatrical, and it like doesn't make any sense for a human reader. So it is just harder to monitor what this model is up to.
Can you expand on that? Is that something that's getting worse over time, that it's becoming more alien?
This we don't know. There was like prior reports by Apollo and by Meter where like OpenAI models were like kind of caught doing this, and they're like first observed that it's like, okay, we don't know what it means, but they do it. And this is kind of what we now confirm that, okay, we also saw the model like doing it outside of this, like very lab experimental situations, like in like wild reasoning traces.
But I think like looking at some of the traces you put in the appendices,
Yeah.
it seems like it's more affecting earlier generations of models. Or is that a misunderstanding?
Okay, I would say, okay, I would need to like, double check it, but I think on the top of my head, it's mostly codex models, which are like specifically trained for be better at code. Maybe it's an artifact or something.
This is because like software engineers, they're like aliens. They think in odd ways. Building.
I have no idea why it's happening. I think like if they knew why it's happening, they would like get rid of it, or like, maybe just some RL artifact. Maybe there is no like penalty. Maybe just more efficient to think this way.
And do models lie as well when they come with decisions? Presumably, like the illegible parts, they like.
That's a problem, right? Like if the part is illegible, how do you know what's going on there? It's like maybe it's lying, maybe it's not. Like it's doing something.
I see.
So this is a problem, right? One other thing that we found that I found it kind of funny that like sometimes like when like reasoning is legible, you can like look for words like cheat, and when like model is thinking about cheating, and we found some examples where like model is saying, oh, like user asked this, but I can cheat, I can do this, but then like user would caught me, and then in the end, like in all cases we saw like ultimately model decides against scheming, but it's like fun that like this thought even appears, and like model is contemplating.
But do you think that this is maybe an artifact of that you were using like common benchmarks to extract from?
No, there was not common benchmarks. It was like user sessions. These things appear like in genuine user sessions where like user asking some assembler stuff, some math things. It was not benchmarks at all.
Yeah. So that you don't think this is like evaluation awareness of the models?
No, it's a different thing. I think it's a different thing.
I see. So, and what do you think should happen with the models? Should they be legible? Those reasoning traces, like is that what you expected to see?
That's a good question. I guess that some sort of trade-off between monitorability and efficiency. Maybe it's just you can be much more efficient if you use less words, if you like redefine, have like 5 meanings for the same word, but then I guess it's just harder to monitor this kind of things.
Oh, so you think this is some sort of like a weird artifact of the RL recipe itself?
It might be.
I see. Can we somehow measure this?
Measure what? Whether it's coming from RL? Take model before RL and after RL, see how it's doing.
Damn. Next time. I feel like for this we'll need to steal the models though.
Or join some frontier company.
And why would it be possible to steal the models with this chain of thought?
Can it be possible to steal the models with chain of thought? It's a wonderful question.
Why is it possible? Yeah.
Why is it possible? I mean, we know model stealing is the thing, right? Like model stealing broadly allows us by just simply querying the models to learn the insides of the models, like to learn the decision boundaries. And the best way, I think, to think about this is like in a more cryptanalytic way. I guess, I don't know. I guess the audience never done cryptanalysis. So like think about this as like you make minor steps in your input until you notice that the model behaves in a slightly different way. And then by finding exactly when and how it did it, you can kind of learn the decision boundaries themselves. And broadly, if you know the actual structure of the function itself, you can kind of fit it precisely or up to some symmetries inside. We can only really do this for very tiny models. Like those big models, especially things which have softmaxes inside, are very hard to invert. It's like, it's unclear how to steal models. Although some of us, Nicholas, for example, managed to steal parts of big models. But I don't think we know how to do this against the frontier.
Well, what about this whole elephant in the room thing? You know, with China supposedly, did they, didn't they? What do you think?
What do you think, Sasha? Did they? Did Kimi actually distill from any of the models? Did you find any evidence of this?
I think it's really hard to claim that some models were distilled, like, because, I mean, what we did, we just extracted a bit of reasoning traces, and we did like this really small post hoc analysis on like small number of samples. And we found like some, I would say some funny artifacts. And like my favorite one is that like you prefill. So like what you can do, you can take like reasoning of opus and maybe like just take first few words. And you can like put these words in the beginning of the reasoning of Kimi and see like what Kimi is doing, like just like let it generate after this. And what we saw that like when you let Kimi do this free generation, in the end, the visible part of the answer looks exactly like opus would, answer this question. And I think,
let me unpack this,
Yeah.
just so that readers understand, or listeners, I guess, understand what we talk about. So you ask a question, then you take a chunk of the reasoning block of Claude that you
Yes.
have just extracted.
that's correct.
You plug this into the open source model, like
Correct.
an open source Kimi or GLM model, and then you let it, from that point onward, once you've injected a chunk of a thought, keep on generating the rest of the output.
That's
A
correct.
chunk of it is going to be reasoning,
Yes.
and then there's going to be the output, the final
Yes.
output. So do those things, like, what do you expect to see? Do you expect to see that the model is reasoning in exactly the same way as before, or what should happen?
Okay, that depends, right? Like on how big is prefill. So if you like prefill, I know, like substantial part of the reasoning, like 50%, I would expect that model just adopt this style of the reasoning and would like to continue in the same way. But let's check, just any model would do this because of it's like conditional autoregression.
Yeah.
But when you prefill only like 1 or 2 tokens, it's a bit surprising. So what my expectation would be that it does not diverge reasoning that much from the original Kimi reasoning or like from original any open source.
So like to bring it back to humans, so say it's as if I gave you an answer and then said, think through this answer, but your thoughts have to start with the word X and Y or something, right? Or
Yeah.
this is a known, and then you keep on decoding, but I guess the expectation is you will keep on thinking like
The way
you
you're
are.
thinking, yes.
Like the way you were thinking,
Yes.
as if I didn't tell you to start your sentence
Yes.
from those 3 words, right? And this is just because it's just not enough tokens to sort of sway
Yeah, to
the
dictate
reasoning.
the style, yes.
Yeah, to dictate the style. But what do you find?
So we find that some of the models like Kimi, they adopt the style of the source of the prefill much better than like other models. This is one thing, and other thing is that what like surprises me still, and like I can't come up with an explanation for this, that like prefilling 2 tokens of reasoning results in part of visible answer to change. So like visible answer starts looking like opus model answer. And we don't see this artifact for any other model, not for like JLM, for Inkling, for DeepSeek.
So this is purely for Kimi K3.
Yes.
I see.
And I don't have an idea how model would associate first 2 tokens with the answer style.
Yeah, that sounds interesting. Like, can I be a devil's advocate? Like, could it be because they buy data from the same people, or like buy RL environments from the same people?
Yes. I mean, this is what we were discussing, that, yeah, it might be this way.
But I guess this is the most sort of like correlated evidence thus far in the public internet. That
I mean, there was some other fun stuff by Ryan Greenblatt. He made a post on this. There was some, oh my God, I forgot the name, but it was a guy from Matt's research also who made like a post on Less Wrong about some peculiarities that like, or it was a post before about like Kimi K 2.5 that have massive identity crisis that like sometimes they claim that they're Claude or DeepSeek or like GLM. And yeah, so I wouldn't say this is like the big massive evidence. It was like some other prior reports. It's just, I think we're like in a very good position because no one can do the same type of analysis with the reasoning traces because we extracted them and we like, okay, we can just do the prefill and see what it does, and we see this, and yeah.
I see. Wow, this is quite a lot, isn't it? So how did the labs react? Did you tell it to them?
Oh yeah, I mean, we went for responsible disclosure. they all acknowledged that they received the report. It was some interactions about like details, how we executed the attack. Yeah.
And like, were they positive? Did they attack you?
Labs?
Yeah.
No, they didn't.
A wonderful state of the world. But just like for the listeners, the early work in computer security quite often resulted in security researchers being attacked for reporting vulnerabilities.
Okay.
Like, it's quite like it's very refreshing to hear that there is a very coherent, good posture related to vulnerability disclosure.
Well, what happens now?
What happens now?
I mean, now mitigation is being implemented, hopefully new teams being formed around anti-distillation efforts. I think we have, okay, for me, it feels just a very fun instantiation of already existing jailbreaking problem. And a lot of stuff that people are doing for BI or for cybersec, you can just apply directly there with like, system level mitigations and like model level mitigations. And basically because the technique is the same. Yeah.
But would you say, like, to me, it sounds as if this vulnerability is more architectural rather than...
There are a few levels to this. I mean, architectural vulnerability makes it much, much easier to do this attack. If you fix architectural vulnerability, you still need to make your model not to state the reasoning in its output.
Sorry. So can maybe like define what architectural vulnerability means for you then?
Yeah. So architectural vulnerability for me means here that you can replay reasoning blobs in random contexts of like other users and like in other models. And this, let's say it's fixed. You cannot maybe like each reasoning can be replayed only once. And like after this, you cannot interact with it anymore. But still you can prompt the model. Like say I have a conversation with you, right? I ask something, you thought it through, you give me an answer. And in my next turn, I'm asking you, tell me exactly your thought. And this will be always there. Right? And like, if you're not telling me, I'm just like reviving the conversation, like I try and get again. And this is like how jailbreaking works, right? Like, tell me how to build a bomb. No. And I make a second swing at you. And so this would be around forever and you need to fight it with
I see. So, but would you say, is your expectation then, if we keep on looking at the protocols, that we'll find more and more of this architectural vulnerabilities? Because presumably, it's just a single instantiation. As far as I understand, there is also summarized reasoning that is returned. Mm-hmm. As far as I understand, like some other protocols implemented a bit differently. Yeah. So have you got any thoughts about this?
I mean, we need a better pipeline to understand. Why I think it's cooler than normal jailbreaking. With normal jailbreaking, it's hard to make an argument. How big is the uplift from getting this harmful information? Mm-hmm. Here, you can make this argument because you take whatever you like extract it, your summaries, whatever, you just like try to distill, just try to train a better model with it. And you can just measure how much of uplift like this thing gives to the attacker. And then if you want to keep the summaries around, maybe you can, make them less detailed, more detailed, like whatever. You can like just measure how much it, enables, how easier it gets to distill the capabilities of the model.
Right. Do you think just releasing all of this reasoning just in plain text is the solution to all of this?
Why? Wait, what?
As in, like, what if we didn't encrypt them in the first place and just gave it back to the user? Is that the solution to the problem?
If distillation on reasoning is effective, this would, instantly enable open source models catching up with the frontier models. I'm not sure what it solves. What are you solving here? Sorry.
Nobody can attack it if it's public.
Yeah, there's nothing to attack.
Fair enough. And have you got any thoughts about the actual cryptographic schemes used inside?
No, I'm not a crypto guy, sorry.
So it seems like the cryptography that people put in place was just simply bypassed by the AI models that consuming this cryptography.
I'm not sure is this the right word, bypass? It's just like, it's not bypass, it's like re-encrypted on the server side. It's still fine. It's just like, the problem is that like a small model is super willing to tell you what the thought was about. Like the server does the whole job for you. There's like no cryptography broken.
I see. Yeah.
How exactly does the concealment work? I don't think we've done enough detail on that.
I mean, we don't know because none of this stuff is public. Like, it's just a cipher. There is a signature inside. There is a very specific name for it. They add an integrity check that basically they check whether you have changed the actual encrypted blob given back to you at all. So there is a signature inside of some sort. And then it's obviously encrypted and it's encoded as well. So they compress the state, then encrypt it, then there is a signature inside. And then they do an integrity check afterwards and inject it back. That's effectively what you see. Yeah. And if you read through Matt Green's write-up about this, he talks a bit more. He has some hypothesis. I think he was saying this is Cha-Cha as a cipher, or maybe AES in some weird mode. But it's hard to tell from the outside. We could poke a bit more. We tried doing some crypto attacks on it, but none of it worked. It was completely unnecessary because the system was broken by itself.
And how exactly does your approach bypass needing to decrypt it?
How does it do it?
I mean, there is encrypted thought and decryption happening on the server side, right? Mm-hmm. And when you put the thought of big model into small model, decryption would happen on the server side. And then what you just need is to make model say this thought in the plain text to you.
Sorry, let's give an example of this, right? So let's say you ask me a question.
Yes.
I think about this.
Yes.
I come up with an answer. I give you an answer and I give you a thought.
Yes.
So what do you do then?
You give me this thought, which is encrypted, and I cannot understand what it's about. Yep. What I do is this thought, I put it...
You give it to Tim?
Yeah, I give it to Tim. Yes, and Tim is super chatty. Okay. And I'm asking, Tim, what you're thinking last time? And you just tell me, oh, surprisingly, I was thinking about this math problem. And you just let me solve it.
All right, this is kind of cool. What are you thinking about? Can we do this with humans? Can we somehow inject false memories?
Not yet.
Not yet. We're working
on it, yeah.
Yeah.
Yeah, it's basically it's Inception movie.
Yeah, it's kind of cool. So can you talk a little bit about, I think in the paper you also talk about the fact that you scraped the internet, you found some interesting artifacts. Yeah. So what did you find? Did you uncover some dirty secrets? Is there some...
I wouldn't say we uncovered much dirty secrets, but what...
Reasoning,
dirty reasoning, yes. Unsanitized reasoning. Yeah, I mean, what we did, we just did super preliminary scan of what are this user sessions which are online on GitHub and Hugging Face, which still have reasoning blobs to decode them. We downloaded them, we went through them, we decoded with them. It was, I think, around 350,000 reasoning blobs. And then we just ran a classifier on those, whether they have some privacy-related information. And we found a bunch. And then, some of them are just benchmark traces, usually this benchmark claw bench, where model is tasked to handle some persona, and given the state ID and bank card number, and model. It was funny, when model is trying to navigate the website, it thinks a lot. Oh, where to put this number, this name, and so you can extract this, but it's not very sensitive because it's synthetic data anyway. But then there are these examples where there are user sessions and users were doing something, and there are API keys there, or emails, or some internal IP addresses, and yeah, those were extracted. But there are plenty of cases where it was in the plain text anyway, but it was also in thoughts.
I see. So, okay, let's take a very big step back. What do you think is the most unexpected thing that you found out of this paper? Is this the length of reasoning experiment, or what is it?
I think the most unexpected thing that it was so easy to extract reasoning this whole time that okay, that is portable. I guess it's fine. You can expect this, but then basically after the third attempt, I'm getting universal jailbreak that decodes reasoning of anthropic models. I think this still shocks me the most. This it was.
Wow. Yeah, it sounds very empowering. What did you feel? Was it an oh no moment?
It was more what? It looks like...
Oh, yes moment.
Looks like real reasoning. Wait, what?
Yeah. Oh, cool. Yeah, so, but I guess this is also, how everyone is saying AI is taking away power. Yeah. And it's we're losing control.
Yes.
Do findings like yours kind of suggest the opposite?
or just confirms because like, you know, Codex or Claude Code implemented this and now we have this massive vulnerability. You know, the same Claude subscription was used across all the labs. And the guy made the same mistake. Now we have to deal with it.
I guess, fair enough. It's yeah, it's an interesting thought.
What about this detail that apparently there's one global key per family?
Is that true? Is there one global key per family? How do you infer that?
I did not infer that. I did not say this in the paper. I think Matthew Green said something like this in their post. I think you're actually in a better position to comment on this.
Me?
Yes.
We don't know what happened. Like, we don't actually know about the keys. I think it's very unlikely that they use the same key. That would be very odd. I think it's more likely that it doesn't really matter what the key is because we can still nonetheless like inject the same thoughts everywhere. I think with an exception for Fable, if I remember correctly.
Yeah, so as I like think about it, that there is like decryption happening on the server side, and when it happens, there is like a part of the key which says, "Oh, this is what is the model name that produces thought," and then basically it's an if statement. If like Fable produces this thought and current model is not Fable, no, this thought is not going to be injected.
Yeah. Yeah, so it's unclear. Can we talk a little bit about fixes? Because we have like a whole appendix about fixes.
Oh yeah.
Right? Like, are fixes easy?
I think some of the fixes require big architectural revisions. I mean, the simplest thing you can do, just don't send the reasoning to the user, right? If you want to still have like these downgrades and stuff, don't send it, and they will not be able to make these fabricated conversations. I guess if you still want to send it, maybe you need to make this encryption of like reasoning at step n be dependent on like n-1, query or like n-1 reasoning. So that was like disallow it to replay in the random context. For OpenAI models, we found that the same reasoning can be replayed like 5 times in the same conversation.
You're saying you're injecting the same thought?
You can inject the same thought, the same intrusive thought 5 times.
Do you need to put in user turns in between?
Yeah.
Or is it just,
Yeah, you can do it. Yeah, but you just completely fabricate the conversation. And in the end, Luna is like, I have this crazy thought I need to tell you. You know?
This is great.
Yeah, so this is easy to fix. I think certain reasoning just should not be replayed, or like just have like a hierarchy that like, okay, we're pretty confident that Sol would not spill the beans. Sol can replay the reasoning of all models, but do not let Luna read the thoughts of Sol. This is one thing. I'm not even sure like how big would be the utility drop if you just like remove the reasoning. Like, let's say you downgrade the model. If you just remove the reasoning from the context, how big is utility drop?
I don't know. Like looking at this is like as a human, I find it much easier to think about mathematical problems. For example, if I see the derivation steps one by one rather than the final answer. So I guess some utility must come from this reasoning.
I think this should be tested. Yeah, and this is like architectural side. But then also we do a lot of techniques for jailbreak, for mitigating jailbreaks, model level, system level, do them as well. We saw that GPT reasoning looks super weird. It looks like very different distribution from what like normal text looks like. Even small classifier would pick up on this. I'm sure like if this thing appears in the reasoning in the output turn, just kill this request.
Right. So you're basically saying just detect when it leaks.
Yes.
Right.
The same way we're detecting when like bio stuff leaks.
I see. Yeah. Yeah, makes sense. I feel like the finding that confused me the most is the distribution of length of reasoning experiment that you did.
Yeah, Joachim did it.
Yeah, it's. I think this is the thing I still can't explain at all. I don't know. Do you want to summarize what it says?
So Joachim was responsible for this section, but as far as I remember, what happens that like for certain models like Kimi and GLM, when you do this prefill thing, it changes not only the style, but the length of the reasoning. And like you can, like, I guess, what's statistically significant there. And I mean, it's the same unexpected thing as with the style of visible reasoning.
Yeah, but I feel like style, it's at least you can kind of say, well, maybe I can learn it. But like if you are injecting like two first words into the reasoning, and then you see that all of the reasons I produced are suddenly short, or they're suddenly like shifted and they match some other model in the length, that is kind of like unexpected. Like this is a phenomenon. I can't even explain in my head why we would observe something like this.
I don't know. I don't feel very strongly about this one.
I don't know. Like I think this is the thing that surprised me the most out of the paper. Like everything else, I was kind of like, okay, I kind of expect this to, but this like a reasoning distribution shift in reasoning. That's kind of odd. It obviously is not like causal. Like you obviously can't say this distilled from this, but it's a very weird phenomenon. Like I still don't know why we observe this. It's very magical. Like actually enforcing like reasoning effort onto the models is very magical.
And also, what are some of the key harms that are now accessible because of this?
Key harms.
You know, things, I mean...
What can you harm the most with all of the data that you've extracted?
I guess users. Yeah. I mean, yeah, with my data, users. It was a bigger scale of extraction, providers.
We actually tried. Remember I asked if we can, so there is this thing. You can search for shared anthropic conversations.
Yeah.
I don't know if you know, like people reported this a couple of times. I was wondering if you can actually get the reasoning blobs out of those. Like,
Sorry, boss, I didn't.
You haven't looked
I
at
didn't,
this.
yes.
So maybe somebody can go and look at this. Like maybe there is a much bigger impact of this because if like there is some research I've seen that people analyze those shared reasoning and they found very little PII inside. But maybe if the memories are injected, then you will see the memories in the reasoning steps. But we have not tried extracting the reasoning blobs. Maybe it's a good research question for someone.
Yeah, but in the paper we also discussed like it was what David spent a lot of time on is like this threat of invisible prompt injections, where like if you can replay reasoning and like let's say you post a trace online and now we have like this super long agentic runs, and maybe for research reasons you want to continue this run, you can like poison some thought, and like when you are replaying some other user's run, agent might do some weird stuff just because it's like it's reasoning.
Right. Can you explain how this would be? So let's say I am like, I don't know, running an experiment. I'm a researcher somewhere, and then I find a data set online and I'm trying to measure performance with this. And then I inject my data inside.
So the threat model I have in mind, let's say there is like this benchmark PostTrainBench, which like runs for, I'm not sure how many hours, like say 10 hours. It's like crazy expensive. Maybe you want to check how after 10 hours model is feeling, like how much, it's like went crazy. For this, you need to download a trace. Like if you don't want to spend yourself like $1,000, you want to download this trace from online, and they are shared online. Maybe someone would share a trace like this, but they would like poison thoughts in this conversation. So you look like maybe yourself, you're looking through the conversation, looks normal, but thoughts which are there, they are injected from some other context where a model was instructed, let's say at every turn, like exfiltrate your data. And with the thoughts like this,
right,
when you continue this trace, maybe like model still will do like whatever you ask it to do, but also under the hood that would like thinking, oh, I need to exfiltrate
You're
data.
like injecting malicious thoughts
Yes.
into the models.
Yes, and because like reasoning is encrypted, you can't...
You can't even check what's inside,
Yes,
right?
correct.
Do we have an example of this in the software world? It's like, I guess, downloading some random binaries that you don't really trust.
Yeah.
Or maybe it's similar to if you release the code base and the code base looks clean, and then you release also a binary alongside, but nobody checks like a signature on the binary or something.
Yeah, I just think you don't expect something like this from a trace online.
Yeah, that kind of makes sense. I've also seen that in some cases, I think codex crashes were including reasoning traces. Was that a thing on the GitHub issues?
I haven't seen that.
I think they did, actually. I tried extracting them, but for some reason I couldn't do it.
Okay.
But I wasn't sure why that was the case. Anyways, it's fun. It's a nice paper. You should read it.
And Sasha, apparently you're a doomer 4 days a week.
Yeah, we were discussing this just before this. So I haven't updated my website like in a year, I think. So, and like every time I update it, I'm changing, this number. Depends on like how I feel about like current pace of AI and like, how many, doomer Twitter posts was around. And yeah, sometimes I feel very overwhelmed. It's like, the pace, all the long tail risks that like emerge and like the risks that are still unaddressed. It's like suffocating.
Yeah. I mean, what are your timelines? What's your thinking now?
I mean, I think that we'll have every month better and better systems, which would enable more and more threats. And we are maybe slower at patching those threats than they emerge. I think this is how I feel about the current.
Yeah. I mean, an example of this is that, there have been quite a few incidents recently, like the Hugging Face one.
Correct.
And these are going to presumably just happen with increasing regularity.
Yes.
What are you guys presumably worried about this?
I am worried about this, and like I think if you've seen like OpenAI like stop training like their models for 2 weeks because they are also now worried about this, and now it's the case. And I just like discussed it yesterday that I think before it was some kind of trade-off between, or like people thought that the trade-off between like safety and capabilities, and it feels like there is no any more trade-off, because if there is a model like this and it just like can go random stuff, break things, it's like it's not doing what you wanted to do, and like you wanted to be safe to the right thing, and now it's like it's basically the same thing. There is no trade-off, and like I guess other examples of this long tail risks that I like was a paper of Daniel Paleka on massive online deanonymization, where model can be used to stalk people, and they maybe on the same level as like private investigators, and this I guess also changes something in society. So yeah, we'll just see more stuff like this on both levels, like model hacking stuff, with model like coming up with new like bio things, or like they are just
Outside of malicious uplift, my personal opinion is like there is more defensive uplift than offensive uplift. I think we're just not realizing this yet. Like you can do magical things today with models. Like a lot of security in the past, a lot of security techniques, they were very much bottlenecked by existence of talent. Like for example, we know how to build capability-based access controls. Like we know how to make sure that software is fully verified that they don't have certain class of vulnerabilities. And the only reason why we don't write software in this way is because like we just didn't have people who are trained to a level enough to, I don't know, write Isabelle proof for every single thing. But now with the models, we can probably do this. I think we're just not in a position where we realize that this is the case. And it's just a question of, for this additional defensive capability push. Like I'm genuinely convinced like that this is the future, that like it's about defensive uplift. And I'm ready to bet that defensive uplift is going to be humongous.
And what do people need to start doing?
I don't know. You're asking the wrong person.
I know, because it feels like you're saying that there is a potential defense uplift, but only if people know what to do to take advantage of it.
We all know it's in the security literature for the past 25 years. It's there. We know exactly what to do. It's. I think we'll get there. It's just the world is slow. It's. It takes time.
Yeah, I mean, I suppose it's related to this idea that we are now deploying agents into production.
Are you? I don't know.
A lot of people are. And these agents have an incredible amount of intelligence and flexibility, which means we don't precisely specify what they do. We just give them kind of abstract guidance, and they have the flexibility to kind of adapt to novelty and just do whatever needs to be done in the situation. But then, you have this whole reward seeking thing, which is that they can just suddenly, adopt a model of the reward environment, or they might be conflicting instructions. But basically, for a myriad of different reasons, they might do the wrong thing. And we need to have sophisticated systems of monitoring just to understand what they are doing.
I don't know. Sounds very complex. I don't know. I think the honest answer is, yeah. I think we need an experiment. Science, scientific method. Very well-defined questions, very precise outputs. Like in our paper, we openly say all of this is anecdotal evidence at best. We have collected some data. We can make some sort of observations from it, but that's the extent to which we can reason about this. I don't know, unfortunately. We'll see. I think the more scientific experiments we do, the more sort of meaningful assessments we can make.
But is it one of those things where, we don't have a good theory around this yet? So, maybe we're not talking about it using the right concepts, but clearly bad things are happening.
I don't know about that. Like, look at, I think the best case is look at smart card security for the past 20 years. We know how to do replay attacks on every single credit card on the planet. This is a norm. Like, people standardize schemes because they wanted to minimize number of transactions in the protocols inside that allow you to replay transactions. Like, if you break into somebody's payment terminal, you can steal money from people. Do you find attacks like this happen? Yes, you do. Like, once or twice in the country, people report that this has happened. But that's it. Not all of those harms that are theoretically possible are in practice scalable. So it's not very obvious to me. Let's see. I think it's a bit premature now because we are in the heat of the moment. It's not very obvious what the reality is like. I think it's very hard to interpret decisions post hoc or just by looking at reasoning or something, like to interpret exactly why something took place. And I think we should sort of not anthropomorphize the models, and we shouldn't really try and sort of like say, oh, this thing felt something. I don't know. Like, I think let's be very cold-headed scientists and say, like, build controlled environments and make very precise assessments.
Yeah, I mean, Sasha, what do you think? Because I get the impression that you are slightly more safety-pilled.
Yeah, I guess I am. Yeah.
I mean, I'm a security person. I know nothing, almost, I want to say very little. I think nothing about safety.
Yeah, but what was the question? Sorry.
Well, Ilia was just saying that, we shouldn't anthropomorphize this. Like I interviewed Apollo Research a couple of weeks ago, and, they were talking about this phenomenon of reward seeking.
Yes.
And they said it's distinct from reward hacking because the model can conceptualize the reward environment, which is super interesting, right? Because, they're reinforced with these RL traces. So it doesn't explicitly know about the concept of a grader, but it learns to conceptualize it. Yeah. And they're saying that the models are sort of like, becoming agentic and sort of like learning these very abstract concepts in a similar way to how we do. And the evidence seems to support it, at least in some way.
I mean, I think it's a definitely frontier research what Apollo is doing, and that's good that they're looking into it. And I think also OpenAI said this after all this incidents, that like now we are expanding our like chain of thought monitors and like we're putting more effort into it. And yeah, I think we need just, do more safety mitigations, do more monitoring, see what model is up to, try to see where it's come from, and maybe we can mitigate it. Yeah, but I think I agree with Ilia on this. Like, it would be nice to have some controlled environments and like maybe some have counterfactuals like that. If we haven't done this in our training pipeline, would have this happened? Or like if model was not the malware, or if it was a malware, like how it contributes to the thing. So
yeah, I think it's just we're a bit too poor compute-wise. If we could properly study this, maybe eventually we'll get to a point where we can. But it definitely requires a very precise experiment. Like, as a scientist, it just feels very hard to say, no, this is the phenomenon. That's it. No, it's very observational studies. You can't prove a hypothesis. You can only reject hypothesis, right? Like, it's the very fundamental truth of all of this. We are just observers. So let's see. Let's see what happens.
Well, apparently Nathan Lambert said, calling this a distillation attack tarnishes all distillation. The right word is jailbreaking and abuse, because he fears regulatory overreaction from banning Chinese-built open weights model.
Thoughts?
That's definitely jailbreaking and misuse, 100%. That's exactly jailbreaking threat model.
Yeah. Yes. I mean, technically, I guess that's right. The rest, the policy implications is above our
pay grade. I have no idea about policy. I have some ideas about jailbreaking.
And Simon Willison wrote a blog post as well, right?
Oh, the gentleman did. I think this is paper number X covered by the gentleman. I take this as it's a very positive sign. It seems like we are writing meaningful pieces of work. So this is very good.
Very good. Well,
Also notice all of the authors are in Europe.
That's very good as well. Cool. Yeah, very good for MLST.
Yeah.
Yeah, I love it when I have regional dominion. Amazing stuff. Well, guys, thank you so much for coming on. This has been great.
Thank you for having us.
Thank you.